So first option talks about the charge distribution. So if this is electric field, del dot E is equal to rho by epsilon naught. So rho is the charge distribution. So calculate del dot E. So del dot E is given by del by del x. So it is, ध्यान से देखना, del by del x of e to the power minus y square plus del by del y of e to the power minus x square. This is 0. So that means rho is equal to 0. So R has no charge distribution. Okay? No charge distribution, but also it is, they want to talk about Faraday's law. So del cross E is equal to minus del B by del T. So divergence is 0. So maybe curl is there. You have to check. So it will be I cap, J cap, K cap, del by del x, del by del y, del by del z, and e to the power minus y square, e to the power minus x square, and 0. So when you take J cap, you are getting something. I cap is 0 minus 0, and minus J cap is del by del x of this is finite, and del by del y of this is also finite. Okay, so when you take J cap, it is this minus this. So take K cap. K cap will be minus 2x e to the power minus x square minus plus 2y e to the power minus y square. So this curl of this is not equal to 0. That means B can be calculated. Magnetic field will be, so R has a d by del B by del T is not equal to 0. That means magnetic field itself is time dependent. So we will get a time dependent magnetic field. Okay, and obviously we will get energy densities also, because you have electric field, you have magnetic field. So you will calculate energy density as 1 upon 2 epsilon naught E square plus 1 upon 2 mu naught B square. Okay, class 12, U is equal to 1 by 2 epsilon naught E square plus 1 by 2 mu naught B square. Okay, so this will be your energy density. So obviously both are there, we will be able to calculate. Okay, yes.